Hello, everyone, and welcome to, I don't remember what week it is, but we're doing Module 3, Part 2. I'm in my new office at home. Things are painted, feeling good, so hopefully you are too. So I'm going to share my screen, and we are going to go over really going back into data cleansing. We're going to do a little bit of a review of last week, jump into what we're doing this week. We're really taking this material one step at a time. So don't feel, hopefully you don't feel overwhelmed. And as long as you get what we're doing that particular week, it will all start to come together. So we are really just starting at the beginning of text mining, text analytics, because we want to get the data in good shape before we really try to do anything with it. So let's dive in. Last week we covered some fancy words, but really pretty decently easy topics. So remember, in text analytics, we have a corpus. That's our data set. And instead of rows, we like to call them documents. So sometimes that's a paragraph or a line of a text. Sometimes it's an entire actual document. So maybe we have a series of documents. Maybe it's a chapter in a book or a page in a book. But we're in general just breaking down that large corpus or data set into smaller pieces that we want to analyze. From there, in each document, in each page, in each whatever we're looking at, we have tokens, usually words, sometimes not, but usually words, because we're trying to break down this even further. In a traditional data set, think anything you've analyzed for any class, you've got rows and columns, and the columns are your features. So maybe we have each country and their GDP and their tariff rates and whatever it may be. This is the same thing, except in text, because we've got text, we're going to use text. We are going to break down those tokens, those words, and we're going to try to get numbers out of them. In this case, we used frequencies using count vectorizer, but we want to count up what we have so we can put numbers to the unstructured text that we have. So tokenization, break a document into tokens. So break a row into lots of different columns. In vectorization, we've got that document, and this is where we really make the rows and columns, if that makes sense. For a vector, we're going into, we want to make a sparse matrix. So again, if you haven't taken linear algebra, don't worry. This is the most algebraic we're going to get. But we have a sparse matrix, which means that we've got rows and columns, but in most of our values, most of them are going to be 0. And that's because the columns are all of the words, all of the tokens available in our corpus or data set, and we want to count up how many times it's used. Most documents are not going to use every single word, which makes sense if you're looking at our BBC News data set, for example. Most of the words are going to be used in a few select news articles, but not all of them. When we get into feature space, this is where we're really looking at our data set as a data set. We're thinking about what features could inform my research, or what columns do I want to pull out from the data that I have so I can actually do something with it. We also looked into count vectorizer, which is a method in scikit-learn that does all of this for us. So while we're looking at kind of technical things, count vectorizer does all of this for us in a few short lines of code, and you're done. And then we also looked at parameter setting. That's a really big part of many things in data science when we're using Python. We're using it because we have more control over the data that we use and create, which means we also have a lot of decisions to make, and that's where parameter setting comes in. We want to better understand the data that we have and the data that we want, and we're going to use the parameter setting to tweak it just how we like it. So for the rest of Module 3, this week we're going over TF-IDF vectorizer. It's a method I introduced just briefly last week, and we're going to look at word frequencies and word clouds. And then next week, we're going to wrap up module 3 with stop words, stemming and lemming, which I will explain, custom replacement, and part of speech tagging. Now, as I say all of this, I am trying to better organize our Brightspace page so everything's kind of all in one spot. So you will notice all of this is still under module 3. And the module numbers don't matter whatsoever. It's just so you can kind of keep track of what we're talking about. And this whole thing we're talking about the next few weeks is data cleansing. So we already got our data, but now what do we do with it? All right. So last week when we talked about vectorization output, this is that sparse matrix where most of the values are 0, or honestly, in this one, I didn't put in the numbers because it was taking too long. So that's sparse. It's pretty empty. There are some numbers in here. And remember, it's a numeric representation of a sparse matrix. So we want each row to represent the actual tokens that are in the document, but it's sparse because not every single document is going to have every word. So that was vectorization. The rows represent observations or documents. The columns represent features. So when we talk about our feature space, it is just all of the tokens that we're using out of our corpus. Feature space could mean we're using every single token. It could mean that we are using a select few. It could mean that we're using a combination. So maybe the words and the most common phrases, we can do that. But all of this depends on what we're trying to do with the data set. And then as we get into feature engineering, my Zoom menu's always in the wrong spot. Hopefully you don't see that moving around. So the feature engineering is how do we handle this data? And that's where we got into, do we use stop words? Do we make things lowercase so that everything is in the same case? Do we leave things as they are? And that's where a lot of that decision making comes in. So you can understand, for example, if we're looking at the I have a dream speech from MLK, what do we do with some of these words? How do we look at historically some of the words that they are using, and how do we group them together so we can make more sense out of the actual text? And the kind of interesting thing with text analytics is that we are trying to do some natural language processing, which means that we're trying to do all these technical things on our natural language, which can be difficult. Even just as I'm speaking now, think of the words that I'm using. Think of the pauses and intonations and the filler words that I'm using when I can't think of my next word. That's all part of speech. It's all part of that human language. So we're taking a lot of the human out of the speech when we use text analytics, and that's where we try to bring it back in with the parameter setting. We're trying to figure out exactly how we want to handle the data, what we want in, what we want out. And then again, with feature engineering, some of the things we were looking at, punctuation, should we take that out? Should we leave it in? Case, so lowercase, uppercase, terms that are informative. So looking at stop words, things like the, of, as, a, again, things that we need so we don't speak like Cookie Monster, but words that might not actually add a lot of meaning. And some of the other things we're going to look at are custom replacements next week. So you'll notice in the BBC News, for example, you'll notice a lot of new. That's a really big popular word in the data set. And you'll notice that York is also there. So it's probably New York. Maybe we do something so every time New and York are right there together, we call it New York State or something, so that we know that it's not talking about new like something fresh. We're not talking about York like any other York. We're talking about New York as an entity. So just some of the fun things to consider with text. And this is, again, some review. We're taking out some of the filler words. We did the lowercase. And Is that all I put in I think that's all I put in the slides because most of it's in the code. So let me jump over there. So again, last week we did the count vectorizer, and I have a really quick review here. All of these first two things are going to be the same. So package imports, we're getting in that count vectorizer. We're still using the BBC News webs or CSV that is on Brightspace. We're going to be using that all term. So bring that in. Let's view the first few rows. Okay, so we've got the title, publication date, some IDs, but what I'm really looking at is the description. So what's going on in that text? And also a fun thing I added in this week just to make it easier for you, table of contents. So now you can like click on something and it goes to that section. So super fun. There we go. So a review of count vectorizer, we are taking these tokens from our documents and our corpus. So corpus, documents, and then tokens are going to be the columns, and we are counting. So in this case, we have, let's see, binary equals false, which means when we're counting, we're going to continuously count. It's not just going to be 1 or 0. Either it's there or it's not. We're going to count by frequency. We took out the stop words, and then we put an MNDF of 0.01, which means that the words need to be in at least 1% of all of the documents, or else we're not going to use it, which means we just want words that are more common. I'm using this as an example. You can play around with it and see what you like. So we're going to do that. And it's now defined, so it's just CV1. But to actually say, now do that, we're going to do CV1 fit transform, and we're going to tell it what to transform. So in this case, it's our data set and our column called description. And I'm saving that to CV1 news. And then once we look at the shape of this, we can see how many tokens we end up having. In this case, it is 84. So out of the 34,000 news articles, there are 84 unique tokens that fit these parameters. Stop words equals English, so we're not using any stop words. And each token has to be in at least 1% of all of the documents. And that leaves us with 84 tokens. Now, if we want to see that, all we have to do is we're going to take essentially the sparse matrix that's made, and we're going to get the column names are the features. So I'm giving you the code here. And that's what it looks like. I did change the settings in this notebook up here. Let's see. So this one, the max column width, and then display max columns equals none. That just means now you can see more of the data set. I didn't do that with the rows because it just gets really busy on the page. So just know that that's happening, which means as you get down here, you see more of these tokens and you can scroll over, which is pretty neat. And remember, it's sparse, so most of these are going to be zeros. That's very normal. You see the ones every so often. Surprising, I don't see anything higher than 1, but I am just looking at the first few and the last few rows. Yeah, so that was count vectorizer. We're counting, we've got a vectorizer, but oftentimes we don't want to count. We actually want to look at what's most important in words, and it's not always just the most common word you use. And that's where TF-IDF comes in. This is, it stands for Term Frequency Inverse Document Frequency Vectorizer. I'm just going to call it TF-IDF. And the basic idea of this is that instead of counting, so instead of frequencies, we're going to weight the basically the importance of each token. And the way it does this, there's some documentation here, and like how does it work if you want to look into the math behind it. But it essentially is saying how important is a word. And we're going to figure that out by saying if a word is used in every single document, if it's super common, that means it's less important. If it is used once in the entire corpus, it's probably less important. But if it's used in a small portion of documents pretty frequently, so a small subgroup of our data set use this token frequently, it's more important. And in this case, when we get these weights, the weights won't mean a lot to us, except that a higher weight is more important. And I won't bore you with all the math, but it is on this page if you want to look through it. But to do that, we just do a few things. We're going to import our packages. And in this case, it's just TF-IDF vectorizer. I'm going to use the exact same parameters as I did with the count vectorizer, except binary is not part of it. So min-df is 0.01, stop words is English. And then the exact same thing that we did with count vectorizer. We take that method that we've set with all the parameters, and now we need to send it to that part of our data set. So I'm calling it TV1 news instead of CV1 news. Transform. And now I'm going to print the shape. And you'll see it's still 84 tokens. So we're still getting the exact same tokens, but it's going to be a little different. And you see now what I mean. So the zeros now have decimals, which is just showing that if it has decimals, that means other values in the column also have decimals. But you see now where country was a 1 on this, I'm pretty sure. Yep, country was a 1. Now it's 0.67. Let's find my next one. Died was a 1 in number 3. Now it's 0.59. So you see a 1 does not always equal that 0.67. It is weighted by the number of times it's seen in other documents, and if it's more or less common. There's a whole mathematical formula if you're really interested. So the weight is highest when T occurs many times within a small number of documents, which means if a small number of news articles have this very specific word, for example, Hamas, that's a big one that's going to be in a lot of these because of the situation in Gaza. So that means it's going to stand out as a higher weighted token versus something like days. Days is going to be used in quite a few documents because we're always talking about days in relation to other things. Weight is lower when the term occurs fewer times in a document or occurs in many documents. So if it is used all over the place or if it's only used in one document, it's not very significant. And then the weight is lowest when it's in every single document. So highest is when small number of documents have it. And then we can also compare these methods a different way. I'm looking at the minimum and maximum value. So CV was our count vectorizer. The minimum should be 0, and the maximum we'll find out. If we were using binary equals true, it'd be 1. But since we weren't doing that, it just depends on how many times each token was used. So minimum and maximum from that first method are 0 and 3. Now we can look at that for TF-IDF. Since it's weighted, it's going to be different. And you'll see it's between 0 and 1. So that means our data set figures are now in a smaller, more normalized area, path, whatever you want to call it. And I put a little note here kind of explaining why that's important. In certain data science methods, when you're doing things like predictive modeling, that scale of your features are really important. You wouldn't want to say compare a binary, a 1 and 0, to something like income, which would be 0 to 500,000. You want things on the same scale as much as possible. So when we do that with TF-IDF, this sets it up really, really nicely for other data science projects we might have with this data set. For you all, we're not going to get into that as much. I will say personally, I like TF-IDF because of those weights. It puts things on a nice scale for other things. But then it also does a good job of pointing out those really important words where the frequencies won't always capture the nuance between the documents. It's really good at looking at overall what's my most common word. But once we get into how do we compare different documents, how do we start grouping them together with like documents, that TF-IDF is the one I go to. So that was TF IDF, short and sweet. Really dive in and start playing around with that and see what kind of weights you get. And then the last two things we're going over in this video are actually pretty simple. With Count Vectorizer, we counted how many times words were used, which means we are just one step away from having a list of most common words. So I'm going to show you how to do that. To do this, make sure if I'm getting the feature names of my vectorizer and I'm counting the number of times each word is used, that means I can't use TF-IDF because that's the weights. I need to use count vectorizer and binary equals false. Super important to do that. When I do that, I can save with that get feature names just like we did before. I'm going to save it to a variable called features. I'm going to sum the frequencies, which means I take that transformed vectorizer, which I called CV1 news. And just to break it down, if you want to know the details, I'm putting that to an array. I'm summing everything, and then I'm making a list. But in general, all you have to do is change this to the vectorizer that you did. I'm going to create a data frame, which again, if you did everything like I did right here, you can just run this as is. And then I see my most common words. So here it's says, world, England, BBC, people, and then it jumps down a little bit to the less common words, not least common because I did that MNDF in this, but this one shows that tells is part of that. So pretty short and sweet, nice and easy. It's a good one. Just remember, you have to use count vectorizer because we have to count to get frequencies, and you have to use binary equals false, or else the most common word is going to have a frequency of 1, which is not accurate. And then to wrap this up, it wouldn't be text mining, it wouldn't be text analytics in general if we did not make a word cloud. This is the most common visualization technique for text data, and it's because it's really easy to interpret. If you see a word cloud, you know the bigger one is more common, the smaller ones are less common. So I'm going to show you just a quick method of doing this. There's lots of ways to customize, and I will say there's lots of great websites that just do this for you, but while we're in Python, we're going to just do it here. So your first time using this, make sure to run this cell. I've already done this. It won't hurt anything if you run it again, but it just installs word cloud. You import the libraries, and I actually put a tutorial here where I got the code. All of my code, I write a lot of it. A lot of it's from GitHub or ChatGPT. Feel free to use that. Programmers today do not just use their brain for this. If you are not Googling code, you're probably working too hard on this. And then, so from that tutorial website, we're doing this where we're just saying, hey, get me everything in that description column and just string it all together in one big long list. And then I'm not going to go through all the code, but basically give it your column and then tell it little things like what kind of color you want. At some point I want to change the text, the font, because I hate it, but there we go. I don't know why it's always blurry. This one is not the prettiest, I will say. But if you look at this, it should be kind of similar to this. So says world England, say, oh, World Cup, England. Part of this is because it's not using that MNDF. So it's still stop words, but it's not doing the MNDF. So it's doing some slightly different things, but that's our little word cloud. So hopefully that was short and sweet. Have a great week, and I will see you next time. Bye.